Good afternoon and welcome to Webinar Wednesday. Today we are joined by Erik Wikström, Manager Training at RTI. Webinar Wednesday would like to thank our sponsor RTI. RTI provides complete quality assurance solutions for all X-ray modalities and facilities. Click and go solutions for your X-ray QA. For more information, please visit rtigroup.com. Just a quick reminder to save the date for our fall MD Expo. We're headed to the Caribe Royale Hotel in Orlando, Florida from October the 29th to the 31st. So please join us for 3 days of education, networking, and the latest advances in medical technology products and services. For more details, please visit mdexposhow.com. Also, we want you to be up to date on the latest news from the TechNation community. So in the handouts section of your webinar dashboard, you'll find a few PDFs, including the pre-show planner for our HTM mixer in Baltimore next week. That's May the 11th to the 12th. Information on the call for presenters for our October MD Expo in Orlando, and also details about our HTM week contest. Today's webinar is eligible for 1 CE credit from the ACI, and you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. Let's kick off today's webinar by giving away one of our Webinar Wednesday t-shirts to the attendee that can tell me the answer to the following trivia question. The Kentucky Derby takes place this Saturday, so what is the flower used in the winner's garland and also the official symbol of the Derby? Answer now using the questions feature on your dashboard, and I'll reveal the answer at the end of the webinar. We'll wrap up today's presentation with a live Q&A, so please submit your questions anytime using the questions feature on the webinar dashboard. As I mentioned earlier, our presenter today is Erik Wikström, and he will be discussing the importance of traceability in X-ray QA and testing performance. Erik, you may begin whenever you're ready.
All right, thank you very much, Linda and MD Publishing, for giving us this chance to make a presentation and share some of the knowledge from the X-ray QA and testing field. As you said, the topic for today is the importance of traceability in X-ray QA and testing performance. So so we'll discuss that for this time. Just in preparation for that, I'd like to share let's see here. There we go. You can focus on the presentation better this way. Just like to share a little bit about the RTI group and where we are and who we are. So it was founded in 1981 as the first non-invasive KVP meter, the DigiX, already 42 years ago. That's when the first non-invasive system came online. So quite alone at that time. A lot has happened since then. In 2004, we had the Barracuda, which is the first wireless X-ray QA testing platform, utilized the Bluetooth functionality. Then there's been a string of firsts in the field. The transparent detector, the T20, was launched with a smaller footprint to be able to function more easily in the floor of measurements with automatic exposure control. 2010, so that's already now 13 years ago, the first Ocean software generation was launched. So that was what we're working with today as a software of choice for gathering and analyzing data in the X-ray community, X-ray measurements. We have expanded the platform with Cobia in 2011, updated to a Black Piranha in 2014, when we also launched Ocean Quick Check, a second generation of Ocean. 3 years ago, we had the scatter probe launched, added that to the portfolio. It's state-of-the-art regulation size scatter probe with solid state detectors. Also received quite well in the market. MyRTI was launched last year, which is a customer portal for Ocean Next users for easier functionality and easier access to data relating to the use of the instrument and the software. And this year we will be launching MyBox, which is a cloud-based service for data backup and sharing. And that's the data from Ocean, the Ocean software, the measurement data for X-ray testing and QA. So in all, what we offer the market today is a complete solution for all X-ray modalities and facilities. So it's a one-stop shop, we like to think. The coverage is pretty global. The headquarters is up here in Sweden, in the north of Europe, just outside Gothenburg. That's where I am at the moment. So in the background, the sun is still up. It's 8 o'clock p.m. So the sun is still up, probably will set just after 9 o'clock now. We have a sales office in Singapore covering our Asian operations. And Steve, you saw, joined me in the beginning here and on the screen. He runs the US operation, which is based out of New Jersey, Tuaco, New Jersey, where we have both the sales office and a lab for service and calibration of the tools that we have on the market. Of course, we work a lot with global customers, manufacturers of X-ray equipment under our belt and in our functionality horizon. We work a lot with GE as a manufacturer. We cooperate with them when they release new equipment. So we have tested our instruments with their prototypes and their early productions. Same goes for Hologic and for Canon, etc., where we work together to get good or ensure good measurements on all manufacturing machines. So just looking back a little bit, like I said, 40 years ago, this is what the hottest non-invasive X-ray meter looked like. It's the DigiX, and that was the first system that we launched. The first on the market. This is the detector itself. So here we had a circular detector, a ring. Detectors are organized in a ring. A small stepper motor to be able to shift that in to cater to different energy ranges. Here is a display that would then be outside the X-ray field, the brains of the outfit. And of course, already then we had software to help analyze the measurements. So it's not only about gathering the data, it's doing something with the measurement data. That was important already from the start. So we move a little bit forward. 30 years ago, this is what the hottest equipment looked like then. It's the PMX range that we see here, which is quite popular. And I'm sure that some of you have worked with them. And if not, you probably would have seen them somewhere in the storage, the shelf, because there were quite a few that were out in the field and still are in the field. We still get them back for calibration. Solid dose is dedicated for dose only. PMX here, there is both dose and KV. But solid dose is a range that also comes back in for calibration, although they're 30 years old. So they're quite solid, that equipment. And when we move forward yet a little bit, we've got the Barracuda that was launched about 20 years ago, a little bit more than 20 years ago. And a little less than 20 years ago, we have the Piranha, which is the system that the current instruments are based on. That was 20 years ago. If we look then advance to today, we have two main families of products. It's the Piranha family here, which is the high end, where we have a family that has everything from a multi, which does all functionality via RF, only RF, mammo, only mammo, CT, only CT, and dental, which is and dedicated to a certain modality. The Cobia family, like we saw, was introduced in 2010, 2011, and that is RF only and has a built-in display. What is here common with these are that we have Bluetooth connectivity to the Ocean software, which is the display software that we work with, and which is used then to collect and save, analyze data. The latest addition here is the scatter probe, which is not really to scale here. It's the regulation size 100 square centimeters and 10 square centimeters. So it conforms both to the high EC standards and the requirements posed by JFR and FDA. This is not Bluetooth connectable. It's a cable connectivity to the Ocean software where we get the readouts from the scatter probe as well. So for these for the Piranha family, we have a number of external probes then to capture other data. We've got dose probes, CT probes for CT applications, DAP and ion chamber, where we see DAP chambers becoming more and more popular in the dental field, or dental CBCT. MAS, mass probes, both invasive and a clamp on for non-invasive measurements of mass and MA. It clamps on to the high tension cable cathode side by the tube, and a light probe then to check both the ambient light and also the luminescence of the screen. So we have that possibility. So with this, we can then build systems that work well and serves the customers to a large extent. Our customer, the priorities that we find that they appreciate is a fast calibration service where we've got between 8 and 10 days turnaround time. So from when we receive it until it leaves our facilities, it's between 8 and 10 days. So we have transportation back and forth, and you're around 2 weeks. But that's very appreciated. Also appreciated is the 2-year calibration cycle. That's what we recommend. Of course, it's the customer that makes the decision about the calibration cycle, but our recommendation is once every 2 years. We're happy to do it every year if you like, or twice a year, but our recommendation is still twice a year. That's good enough for us. When you maintain the calibration, the 2-year calibration cycle, it's also possible to extend the warranty up to 10 years. And after that, we think it's about time to get a new instrument. But we have the possibility to extend the warranty if you maintain the 2-year calibration cycle. And we have apparently a responsive support team. That's the feedback we get from the field. We offer telephone support during office hours, email, and we have a web support portal that's available through our user portal that we have, which is called My RTI, which is the new features we have for customers today. So that's a little bit about RTI, where we are, where we are at the moment, and where we're aiming a little bit. So today's topic is the importance of traceability, and I thought we'd take a little bit look at what is traceability. When we talk about traceability, what is that? What do we mean really with traceability? So I took the liberty of looking it up in Wikipedia to see what Wikipedia says about traceability. So we have some form of common start for the discussion. And one thing that we saw here is that traceability is the ability to verify the history of an item by documented, recorded identification, but to see that we can verify the history of it. How have we received something? How have we achieved? How have we arrived at a certain conclusion? So with that, can we verify the history of the input to such a discussion or such a reasoning when we arrive arriving at a certain conclusion. So there's then the documented recorded identification. So how do we record it when we want to trace and verify the history? How do we establish that? How can we keep track of a given set of information that we collect? How do we keep track of it? How can we monitor it and ensure that it's that piece of information that we've started with and that we need? So that's another component in the traceability. Then when we talk about metrics, metrology, there's another angle on traceability, and that's that we need to establish or make credible that there is an unbroken chain of comparisons relating to an instrument's measurement and a known standard of calibration, for instance, to a traceable standard. And that's also important, especially for in the regulatory terms and regulatory applications, where we need to prove that what we're actually using a tool that is fit for purpose. So why is then traceability important? Well, in this field, we need to show that when we're collecting data, that a certain instrument has been used. We need to say that the data that we've collected, the measurement that we've made, was made with this specific instrument. And usually we trace it to a serial number of an instrument and a type of instrument, so that we can identify that particular instrument and connect that to a certain measurement data that we've collected. So that's one thing. So that makes it traceable, that this data was taken with that instrument, that specific individual instrument. And once that has been established, we also need to establish that that instrument is properly calibrated. Is it fit for purpose, that specific tool that we've been using? So that is also part of the traceability, and so that we can replicate that measurement, redo it with the same setup of tools, and then we should get the same result. Well, that's part of that chain of traceability. So we need to secure the chain of measurement data. So that's or at least an idea around it, what we could do with it. And one of the reasons, the heavy reasons, the strong reasons of using this is that we have regulatory bodies that require proof that the data that we present for a regulatory test, an inspection, that the data that we provide as proof that yes, this modality or this piece of equipment is fit for purpose, it is safe to use. Of course, then we need to have used proper instrument, and that the data is solid, that we base that conclusion on. If we don't, well, then we might be on a sliding slope and slippery slope, and we may be approving machines that shouldn't be approved and failing machines that are perfectly functioning perfectly well. But the regulatory bodies ask us to check and to verify the calibration of the instruments that are used for that specific purpose, to ensure that the measurements made are correct. We see also that not only from a regulatory body that used to drive this field, this market a lot in the beginning, so that was one of the major driving forces. What we see now is that owners and operators drive that a little bit more than they used to. So they're getting up there also in importance. So they want to, owners and operators of X-ray equipment, so that's hospitals, and that could be clinics, it could be others that lease equipment or that kind of thing, that need to know that the equipment they have, what shape is it in? And to determine that, well, a part of that is tested with the equipment that we provide when doing preventive maintenance tests or yearly tests that are not for a regulatory body, but other tests to ensure that the system is functioning properly. So if you, unless you use a proper instrument, a properly calibrated instrument, and a proper procedure, there may be some question about how solid is the data, how solid is the conclusion regarding the status of the equipment. So that there may be a question mark. If we have traceable data, we can then reduce that the level of doubt when it comes to the status of the equipment. There's also, if they outsource the service and maintenance, even if it's maintained in-house, this could serve as proof that the service is performed and maintenance is performed, and to document that and keep that document for future reference. And to have that documentation valid, well, of course, it survives better if we can prove the traceability, if there is traceable data in those documentations. So, of course, that's the whole idea behind it. They can also then ensure that the comparable data is gathered. That could also be very important if they want to gather a larger database to be able to monitor the performance over time of different equipment. And also if they want to gather and compare data between different equipment, but at the same time. If you have the same generator in an X-ray machine, you or an owner may want to monitor that to see if the performance of of those generators are the same, if they age the same when it comes to tubes. Do we see any changes in HVL over time? To be able to do that, we need good input into a database like that to be able to do a proper comparison. And that will then, if we can trace the data and make sure that yes, everything is okay, they have the same calibration standards, it's the same procedure being used, well, then that data, the chances that it correlates is higher, and it's then easier to accept that as what I call it, input to a conclusion, whether or not the performance is according to is on par compared with other equipment in the field. So there's not only for regulatory requirements is traceability important. We have other avenues that are benefit from a good traceability. Okay, so looking at some examples then, when we're talking about traceability, to make it a little bit more hands-on and a little bit more clear, we'll look at some examples. And first, we'll look at the part that we started with, verifying the history of the data. So just the traditional way of doing that is by documenting and building traceability in a spreadsheet, so-called database. And what you do with that in those cases is typically make a measurement and look at the data and then transfer it into a spreadsheet. And that's either you do it by hand or export it automatically into a spreadsheet. So this is what we do. I mean, we have some exposures. They all seem to be around 70 kV, 70 here, and then we've added it in there. and we're going to, yeah, close to 70 again, but it varies a little bit. They're all around 70 point something kV, and feed it all into a spreadsheet. But what does that, the data, the numbers that we see, how well do they correspond with reality? Say that we have this, and the numbers 69.81 kV, for instance. Is it that, yeah, if we look at this exposure, the red here is the kV, yeah, right, that probably is around 69.81, which is close to 70 kV. So if you write 69.81, is it this exposure waveform? Is that kind of exposure? Is it this generator performance that we're documenting? Or is it this generator performance? Of course, we have a slightly higher here, but negligible. But the waveform is a lot more noisy. It oscillates, it's around 70, but it goes up to, what do we have here, 75, and drops down to something else. Is that 70.08? What that we're documenting, that we're exporting into the Excel spreadsheet. This 69.81. Is this a different signal? Is this different data that we're sticking in here? If you look here at the beginning, 69.81, that was a flat line here, almost really, really nice and square. Then 69.87. This is a very much different signal than we saw before. But is that so? Is that the same data that we're entering into the spreadsheet? Here's another one, 70.38. It oscillates here, goes down to something around 60 and up to 80 kV. So that oscillates around there, but still the data that we're showing is 70.38. And last but not least, here we've got another little bit of an also undulates here down to 60 and spikes up to above 90 kV. But in the Excel spreadsheet, what we have here is 70.27 kV. What information do we have? I mean, if we export this and put that into a spreadsheet, well, the examples that I've shown here is just to illustrate that it seems to me that the information that we input into the spreadsheet, it's truncated. The traceability thereby is also truncated if we only export and only keep the numbers in the spreadsheet. So here is a bit of a, maybe it could be considered a risk, but we're here sacrificing information that is available in a waveform here. We're not making use of it. We're just truncating that and making do with just the digits. So the question is, can the data that we've then put into the data spreadsheet, can we trust that data? Does that data tell the whole story? Secondly, is the origin of the data verifiable? Do we know where that data came from? Was that actually measured, or did somebody just key it in by hand? And in my humble opinion, the trace ends here at the spreadsheet cell. So if we make do with the Excel spreadsheet, yeah, the traceability is truncated. It's cut off. We get no more information than what we have about these numbers. And what we're in effect doing is that we're actually asking people to trust us. Trust me, yeah, it was 70.08 kV in this measurement. Trust me. That's what we're doing in this world. So what could we do to improve that? Well, there is looking at a fit for purpose or a built for purpose software we could then look at the waveforms and collect them in the database, build a database of them. So we have both the data and the waveforms. Then we have all data that we, as much data as we have available here. If we then utilize this, the modern software, well, this is what we'd be able to see. We'll have the values in the cells, all the values, and then we'll also have the waveforms here indexed to the different exposures, so that we can actually see what is behind these digits. Is there something else? And as experts in evaluating performance, we could then see, is this good? Is this good? What do we see? What other information do we get from the waveforms that we as experts can use in our job to determine whether or not the system is fit for purpose, or if it needs to be failed for some reason. We've also here, since the software is then communicating with an instrument directly, we can pick the information about the instrument, i.e. the serial number of it, to identify that for these measurements here, for those, this serial number instruments was used to create that. And then we have another traceability back to further down the chain when it comes to traceability. And in this case, well, what we see here is just the image of the waveform, so, which tells a pretty good story. There are possibilities of going even further when we're looking at it by, if we're using an Ocean template. Here is a simple template where we're also checking for KV. In those, we have the possibility to capture the waveform. If we, from this waveform, we're able to export the data from the waveform, not just the image, or we can use the image if it's a bitmap or JPEG or PNG image of the waveform, but could also be exported as a data file, where the data is then exported in a format suitable, for example, for Excel, where we have each and every sample listed on a row with corresponding timestamp and the measurement value, the value of that individual sample in KV when we're looking at it. So if we have a look, we can see that we've got, it starts off at 9 kV, which is pretty low. That's just when it starts to trigger, and it rises up to 96, up to above 100. Then it oscillates around 85 somewhere, and then so this is where it oscillates. If we then make a graph in Excel out of this, we'll be able to zoom in and check in our own way how that works. So that means that each and every sample is traceable in this example here. So we can, if there is a question or if there is a doubt somewhere, that how did you arrive at this conclusion that you're actually the KD or the dose value, whatever value it is, why did you interpret it at this? Well, here is the proof in the pudding. And also in this case, we can trace the serial number or the measurement to a specific instrument, a serial number of an instrument. And if we do that, we can then also trace that to a known standard. What we said, and this is, we can then go to the user portal to arrive at that conclusion. So this is the user portal where we have a MyRTI account. We can go and click on meters, and then on that, and we'll get a list of the different meters and instruments that we've been using. And if you remember, we had this serial number, that's the one we were using. So if we click on that, we'll see that we get more information about this specific serial number. Among that information we have is here calibration certificates. And if we click on there, we can then see that we get to a calibration certificate. In this case, it's the one for current, but they're all the calibration certificates are available. But there we'll see when it was calibrated, where it was calibrated, what type it was, part number, who performed it, what was the environment, method, traceability. It's traceable to ri.se, which is a Swedish research, it's a Swedish NIST, so it was performed here in Sweden. But it's traceable to national and international measurement standards. So you get all this, and then you get the calibration data. But the important thing here is the calibration traceability of it. So here, in effect, what we can do is that we can trace individual the validity of individual samples of a measurement to a calibration certificate to make that point if necessary. It's it's an extreme, but that's a possibility that we could that could be made. All right, so that's kind of interesting also how that can be, how much further we can move the traceability limits, the limits of traceability from where they are in general today. The feedback we get from the field is that yes, we have full traceability. We store it in our database where we have the Excel spreadsheets and the analysis that we do with the Excel spreadsheets. Well, yeah, that's good and fine, which is quite impressive. But here is a possibility of extending that chain of traceability even further to ensure even higher comfort when it comes to knowing that the data that we're making our assumptions and drawing our conclusions from are solid. Right, so that's when it comes to the measurement side of it, and the tracing of the calibrations, etc. And there's one thing more than verifying the location of the data. Now, if you remember where we started in the beginning, the first 5 exposures, we saved those in a file here, which is called Webinar Wednesday Examples. And that's to say that a file, measurement file that we saved into our database. And that's these measurements, you can recognize them that we saw here. So this is on the measurement computer that we're running the software on it. Now, if you click this button up here with the new software that we're about to release, you'll pop up a screen like this saying that it's synchronizing the database with MyBox. What is MyBox then? Well, it's a function in the user portal, which is a replication of the database onto your cloud account. So MyRTI is a user portal, free for everybody to use. MyBox is an add-on added service we're about to launch, where we'll be getting a replica of the database that we have on our computer. So when we then look at the database, we'll see that we have all the measurements and sites that we have on there, plus the MyRTI database or MyRTI measurement file that is then based on in the database. So it's then saved, it's backed up on MyBox. So if something happens to if you drop the measurement computer, if it gets stolen or it crashes or freezes up or whatever, you have a backup in the cloud with the MyBox account. So there you'll have the possibility to again export it, share it, reload it into another unit if it gets stolen, and from there go back and then trace data all the way down to the individual samples again. So this with this replicated database. And also here it's to be able to trace it and to share that traceability. There's a possibility then of sharing files via MyBox. So via MyBox, there's a possibility to share measurement files and also templates, but share measurement files with other Ocean users so that they also can enjoy or explore that the traceability that we have down to the individual sample. So when we find that, it says share via MyBox, and then it appears in this folder which says shared with others. So I'm sharing with others. So it will show up. This says I'm sharing this one with a certain individual, which is erik.wikström@gmail.com. So we'll have a list here of people that I'm sharing with. And whoever is on the other end will find those in the shared with me folder. When they pop up and say that Erik wants to share something with you, and you can then import the data and or accept that share and then find it in the shared with me folder, measurements or the measurement data or the template files. So this is then you can keep track of who you're sharing it with. So that makes it possible also then to offer traceable data also to others, because in that file, in the measurement file, includes the data of the instrument actually used. So I can share it with somebody else and they will see that it was my instrument being used to collect this information. And that's then valuable to, so it's not only the measurements data itself, but all the information regarding the date when it was the data was captured, what instrument was used to capture that data, and what's the serial number of that. So we have the possibility to trace the data based on that information. So that's a little bit what we can do, and I thought it was an interesting idea to share with you what we can, to what extent we can share, we can extend the traceability of it. Then just to summarize what we've talked about a little bit, it's what we experience when we're out in the field is that the concept of traceability is growing in importance, and there's for several reasons. One of them is that, well, we have stricter regulatory requirements coming up. I mean, we see even now on dental X-ray machines, we see regulatory inspections being mandatory in many states. At least here in Europe, we see that in most countries in Europe. That's also intraoral dental equipment needs to be tested and inspected. And I understand also that in the US and Canadian and North American markets, it's becoming more and more common that also even intraoral, definitely dental CBCT and panoramic dental have been needed testing or inspections several years, but now also intraoral is getting in there. So regulatory requirements are tightening. But also internal quality standards the standards are rising. They're getting higher when it comes to the quality and of maintenance, and also the quality of the service that modality should provide. That means that it needs to be maintained better. And also there's an interest of looking at a broader base, comparing and seeing how these individuals, how is a population of equipment, a common type, how are they performing in comparison to each other? And for that, we need high quality data. When we're out in the field and seeing also, we see that there may be a risk of truncating available traceability. Traceability is available in most instruments, but it's a lot of the time not saved. So it's tossed, truncated in many cases, which is a bit of a pity, because it's difficult to reconstruct once you toss that data. But there are solutions that offer improved traceability. So one is the traceability of measured data. Yeah, we've shown some examples of that. Traceability of instrument calibration to a known reference. Well, that's what we call the traceability or access to a calibration certificate. It's shown here in an easy way, but most of you, I'm sure, have access to the calibration certificates, either in a file, in a binder somewhere, or in a file folder in some drawer somewhere, even maybe a copy with you when you're out in the field. But that needs to be maintained, especially if you're being audited. It needs to be easy to have that at hand. It makes life easier. The traceability of location of data, well, it's with a replicated database accessible from several devices, well, then we have location of data traceable. We know that it's in that database that we have backed up into the cloud. That's where we need to get it, and then we have that full chain of traceability available to us as well. And the improvement of the traceability here, the best thing with that is that it's achievable without additional process steps. If we use a software that maintains this and actually provides this information, all we need to do is save that data, and we have the data at hand, easily accessible with little or no extra effort. And if we utilize the software in a smart way, we can then also provide reports that with this information automatically in there from step one, so that we can maintain data and do better when it comes to traceability in the future. So that's my input on this topic for today. If there are any questions, I'll be glad to answer them.
Thank you, Erik. Yes, we have got a few that have come in. The first one is, if we export the measurement waveforms to Excel, isn't that just as good as traceability?
Yeah, well, in like we saw here, it is possible to export it into the report functionality in the Ocean software. Well, that's as an image, that's JPEG or something like that, which is good, but it doesn't bring us all the way down to the individual sample. And I know that with other softwares and other instruments, it's also possible to export the waveforms in there. But if I'm not mistaken, that's also an image of the waveform, which is fine. It's better than nothing, but it's difficult there to drill down to the individual sample. That may be interesting to when you want to make an even deeper analysis of it. So yeah, that's it's better than having no waveform, definitely. But there are ways of going even further and making that a solid trace.
Okay, and following on from that, is the cloud backup function an extra add-on to the Ocean Next?
Yes, it's an extra service. It's the My RTI account that we showed before here, where you have the access to the calibration certificates. That traceability is free of charge. Everybody can sign up for that, and if you have an instrument, calibrated within the last 12 months, those certificates will be accessible on that account. So that's one way of doing it. And they work also with when you're hooking up the Ocean software, when you're firing that up, the Ocean Next software, it will automatically push up information of what instruments you've been using, so that they pop up under that meters window, showing you that these are the meters I've been using. So that's the My RTI, and that's free for everybody to use, access to the calibration certificates. When it comes to the My Box functionality, backing up the database, the measurement database of Ocean, that's an extra feature, and that's a new functionality that we're offering. We'll be launching it any day now, and that's going to be a paid service, a subscription service for each user. That's on there.
Okay, another question which just come in, just slightly connected to that. Is this software only used for the traceability of radiology equipments, and can this be used for other medical equipment?
Well, it's the traceability, of course, when it comes to the sample data, that is then done with our instruments, where it collects the instrument itself captures the data that makes the measurements, if it's dose or kV or MA or whatever it may be. So that's specifically for X-ray, diagnostic X-ray equipment. So that's the way we can drill all the way down. But in the software itself, we can make templates that we can key in data for other measurements. Of course, then it's a little bit truncated, but it depends on what kind of inspections you want to do.
Okay, so who is responsible for recording this data, a biomed or radiology safety officer?
Depends on recording the data. Well, usually it could be, what we've seen here is that it's a biomedical engineer, typically would be repairing or doing preventive maintenance on X-ray equipment. So they would be one of the possible users of this functionality, to be able to gather information and record it for future use, and also as proof to say that, yes, I've actually worked on this machine, I've tested it, this is the way it was before, and I've changed and modified something, this is what it looks like afterwards, so they can actually prove I did the job on it. So that's for a biomedical engineer. When it comes to radiation safety officer, probably they would be looking at regulatory requirements. Maybe they would be looking at leakage, scatter, and they are needing to document that. That's also another area of operation for the tools that we have. And also definitely for that category, it would be very useful to document what was actually going on. You look at the scatter probe to see the leakage of a tube leakage, for instance. You have that documented, that yes, these are the levels, these are the signals I've got. And I did it at this time with this instrument serial number, so you can actually document everything without having to key it in by hand. That goes all automatically, and you just do your measurements with those things. Also, as a radiation safety officer, you have the overall responsibility for X-ray QA, for the QA procedure, and of course, in that work, part of that is testing X-ray equipment in this way as well.
Okay, that's great. Another question here is, are the calibration certificates on the customer site traceable to NIST?
To NIST, yes. Yes, they are. And both our calibration labs in Sweden, of course, in the calibration lab we have in New Jersey, in our office there, is of course traceable to NIST. That goes without saying. But we have a lab in Sweden as well, and we do interchangeable intercalibrations, so to speak, so that we have traceability between our two labs. So our Swedish lab is traceable to our US lab, and the US lab is traceable to NIST. So there we have an unbroken, we have a chain to verify and to prove and NIST traceability.
Okay, so is the database backed up on an RTI server? If so, where's that located?
Well, I wish we were that beefed up when it comes to IT. Now we're making use of Microsoft Azure servers, and we're buying that service from them. And from what I understand, even the US Department of Defense, some areas there utilize the same service, so we feel quite safe using that. But it's not our own. We outsource it to those professionals who do that for a living, provide safe cloud database storage.
Okay, that's good. Another question here is, can you upload sites and the testing within that site to my box?
Well, it's uploaded automatically. So once you make a measurement and you come back into coverage, internet coverage. Sometimes when you're doing CT testing or when you're in the biomed lab, usually that's in the basement somewhere. Wi-Fi coverage may be spotty. But as soon as when you make the measurements, it goes into the measurement computer, and a synchronization engine works in the background. So once you get back into internet coverage, it will then synchronize and push new data up into the cloud backup. So you have a complete replica of the database in the cloud every time. So and you don't need to do that manually or anything. It does that automatically as soon as you're in coverage.
Okay, we've got time for one more question, and it's for your software Ocean Next. Do you have future plans to have it for iPad or app for the Apple Store?
Well, there's always plans for it. The trouble that we've seen is that to get that working, especially it works on Bluetooth. The software and the functionality is ideal for Bluetooth. To be able to do that with iOS, we need specific Bluetooth components, and to get those, they need to be verified, and you have to jump to all kinds of hoops. Just making an app doesn't really work because there's more to it than just sending a yes or no or a video. It needs strong communication, and the iOS interface, we can't really get to the Bluetooth functionality the way that we'd like to yet. We're exploring it and we're working on it. We'd love to have an iOS app, or but we're not quite there yet. Having said that, we have tested, or I have tested it myself on MacBooks with parallels, and it seems to work quite well on parallels. It's also on Bluetooth, so that's one way of moving forward. But again, then again, it may not be available on iPads or on iPhones. But we're looking at it, and when we find a smart way of doing it, we will. We're not quite there yet. So.
Okay, that's great. Well, we're coming up to our hour, so thank you so much, Erik, for your time today and for a great and informative presentation. I'd like to encourage everyone to visit today's sponsor to learn more about the product they provide for our industry, so please visit rtigroup.com. As promised, the answer to today's trivia question is the red rose, so congratulations to our winner, Corey Robinson. Just a quick reminder, you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. We'll be back soon with another webinar, so please visit webinarwednesday.live for more details and complimentary registration. registration. Thank you again for your time today and enjoy the rest of your day.